Arousal is the physiological and psychological state of being awoken or of sense organs stimulated to a point of perception. It involves activation of the ascending reticular activating system (ARS) in the brain, which mediates wakefulness, the autonomic nervous system, and the endocrine system, leading to increased heart rate and blood pressure in a condition of sensory alertness, desire, mobility, and reactivity. Arousal is mediated by several neural systems. Wakefulness is regulated by the ARS, which is composed of projections from 5 major neurotransmitter systems that originate in the brainstem and form connections extending throughout the cortex. Activity within the ARS is regulated by neurons that release the neurotransmitters norepinephrine, acetylcholine, dopamine, serotonin, and histamine. Activation of these neurons produces an increase in cortical activity and subsequently alertness. Arousal is important in regulating consciousness, attention, alertness, and information processing. It is crucial for motivating certain behaviors, such as mobility, the pursuit of nutrition, the fight or flight response, and sexual activity, the arousal phase of Masters and Johnson's human sexual response cycle. It holds significance within emotion and has been included in theories such as the James Lange theory of emotion. According to Hans Eysenck, differences in baseline arousal level lead people to be extroverts or introverts. The Yerkes-Dodson law states that an optimal level of arousal for performance exists, and too little or too much arousal can adversely affect task performance. One interpretation of the Yerkes-Dodson law is the Easterbrook Q utilization hypothesis. Easterbrook's hypothesis suggests that under high-stress conditions, individuals tend to focus on a narrower set of cues and may overlook relevant information, leading to a decrease in decision-making effectiveness. Neurophysiology. Structures of the brainstem, the origin of the arousal system, viewed along the sagittal plane. Wakefulness is regulated by the ascending reticular activating system, which is composed of 5 major neurotransmitter systems, the norepinephrine, acetylcholine, dopamine, serotonin, and histamine, systems each considered in the paragraphs below that originate in the brainstem and form connections which extend throughout the cerebral cortex. 1, 2, 3. When stimulated, these systems produce cortical activity and alertness. 1, 2. The noradrenergic system is a bundle of axons that originate in the locus coeruleus and ascends up into the neocortex, limbic system, and basal forebrain. Most of the neurons are projected to the posterior cortex, which is important with sensory information and alertness. The activation of the locus coeruleus and release of norepinephrine causes wakefulness and increases vigilance. The neurons that project into the basal forebrain impact cholinergic neurons that results in a flood of acetylcholine into the cerebral cortex. The acetylcholinergic system has its neurons located in the pons and in the basal forebrain. Stimulation of these neurons result in cortical activity, shown from EEG records, and alertness. All of the other 4 neurotransmitters play a role in activating the acetylcholine neurons. Another arousal system, the dopaminergic system, releases dopamine produced by the substantia nigra. The neurons arise in the ventral tegmental area in the midbrain, and projects to the nucleus accumbens, the striatum forebrain, limbic system, and prefrontal cortex. The limbic system is important for control of mood, and the nucleus accumbens signal excitement and arousal. The path terminating in the prefrontal cortex is important in regulating motor movements, especially reward-oriented movements. The serotonergic system has almost all of its serotonergic neurons originating in the raphe nuclei. This system projects to the limbic system and the prefrontal cortex. Stimulation of these axons and release of serotonin causes cortical arousal and impacts locomotion and mood. The neurons of the histaminergic system are in the tuberomammillary nucleus of the hypothalamus. These neurons send pathways to the cerebral cortex, thalamus, and the basal forebrain, where they stimulate the release of acetylcholine into the cerebral cortex. All of these 5 systems are linked and show similar redundancy. The pathways described are ascending pathways, but they're also arousal pathways that descend. One example is the ventrolateral preoptic area, which release GABA reuptake inhibitors, which interrupt wakefulness and arousal. Neurotransmitters of the arousal system, such as acetylcholine and norepinephrine, work to inhibit the ventrolateral preoptic area. Importance. Mental state in terms of challenge level and skill level, according to Csikszentmihalyi's flow model. 4. Click on a fragment of the image to go to the appropriate article. Arousal is important in regulating consciousness, attention, and information processing. It is crucial for motivating certain behaviors, such as mobility, the pursuit of nutrition, the fight or flight response, and sexual activity. See Masters and Johnson's human sexual response cycle, where it is known as the arousal phase. Arousal is also an essential element in many influential theories of emotion, such as the James Lange theory of emotion or the circumplex model. According to Hans Eysenck, differences in baseline arousal level lead people to be either extroverts or introverts. Later research suggests that extroverts and introverts likely have different arousability. Their baseline arousal level is the same, but the response to stimulation is different. 5. The Yerkes-Dodson law states that there's a relationship between arousal and task performance, essentially arguing that there's an optimal level of arousal for performance, and too little or too much arousal can adversely affect task performance. One interpretation of the Yerkes-Dodson law is the Easterbrook Q utilization theory. It predicted that high levels of arousal will lead to attention narrowing, during which the range of cues from the stimulus and the environment decreases. 6. According to this hypothesis, attention will be focused primarily on the arousing details, cues, of the stimulus, so that information central to the source of the emotional arousal will be encoded while peripheral details will not. 7. In positive psychology, arousal is described as a response to a difficult challenge for which the subject has moderate skills. 4. Personality. Introversion and extraversion. Eysenck's theory of arousal describes the different natural frequency or arousal states of the brains of people who are introverted versus people who are extroverted. The theory states that the brains of extroverts are naturally less stimulated, so these types have a predisposition to seek out situations and partake in behaviors that will stimulate arousal. 8. Whereas extroverts are naturally understimulated and therefore actively engage in arousing situations, introverts are naturally overstimulated and therefore avoid intense arousal. Campbell and Holly, 1982, studied the differences in introverts versus extroverts' responses to particular work environments in the library. 9th, the study found that introverts were more likely to choose quiet areas with minimal to no noise or people. Extroverts were more likely to choose areas with much activity with more noise and people. 9th, Dawes and McKelvey's 1986 research showed that introverts performed worse on memory tasks when they were in the presence of music compared to silence. Extroverts were less affected by the presence of music. 9th, similarly, Belajevic, Slepsvik and Jokovic 2001 found that introverts had more concentration problems and fatigue in their mental processing when work was coupled with external noise or distracting factors. 10th, the level of arousal surrounding the individuals greatly affected their ability to perform tasks and behaviors, with the introverts being more affected than the extroverts, because of each's naturally high and low levels of stimulation, respectively. Emotional stability versus introversion-extraversion. Neuroticism or emotional instability and extroversion are 2 factors of the Big 5 personality index. These 2 dimensions of personality describe how a person deals with anxiety-provoking or emotional stimuli as well as how a person behaves in response to relevant and irrelevant external stimuli in their environment. Neurotics experience tense arousal which is characterized by tension and nervousness. Extroverts experience high energetic arousal which is characterized by vigor and energy. 11th Gray 1981 claimed that extroverts have a higher sensitivity to reward signals and to punishment in comparison to introverts. Reward signals aim to raise the energy levels. 11th Therefore, extroverts typically have a higher energetic arousal because of their greater response to rewards. 4 personality types. Hippocrates theorized that there are 4 personality types: choleric, melancholic, sanguine, and phlegmatic. 12th C. Galen. Put in terms of the 5-factor level of personality, choleric people are high in neuroticism and high in extraversion. The choleric react immediately, and the arousal is strong, lasting, and can easily create new excitement about similar situations, ideas, or impressions. 13th Melancholic people are high in neuroticism and low in extraversion, or more introverted. The melancholic are slow to react and it takes time for an impression to be made upon them if any is made at all. However, when aroused by something, melancholics have a deeper and longer lasting reaction, especially when exposed to similar experiences. 13th Sanguine people are low in neuroticism, or more emotionally stable, and high in extraversion. The sanguine are quickly aroused and excited, like the cholerics, but unlike the cholerics, their arousal is shallow, superficial, and shortly leaves them as quickly as it developed. 13th Phlegmatic people are low in neuroticism and low in extraversion. The phlegmatic are slower to react and the arousal is fleeting. 13. The contrasts in the different temperaments come from individuals' variations in a person's brain stem, limbic system, and thalamocortical arousal system. These changes are observed by electroencephalogram (EEG) recordings which monitor brain activity. 14th Limbic system activation is typically linked to neuroticism, with high activation showing high neuroticism. 15th Cortical arousal is associated with introversion-extraversion differences, with high arousal associated with introversion. 15th Both the limbic system and the thalamocortical arousal system are influenced by the brainstem activation. 15th Robinson's study, 1982, concluded that melancholic types have the greatest natural frequencies, or a predominance of excitation, meaning that melancholics who are characterized by introversion have a higher internal level of arousal. 14th Sanguine people, or those with high extraversion and low neuroticism, have the lowest overall levels of internal arousal, or a predominance of inhibition. 14th Melancholics also have the highest overall thalamocortical excitation, whereas cholerics, those with high extraversion and high neuroticism, have the lowest intrinsic thalamocortical excitation. 14. The differences in the internal system levels is the evidence that Eysenck used to explain the differences between the introverted and the extroverted. Ivan Pavlov, the founder of classical conditioning, also partook in temperament studies with animals. Pavlov's findings with animals are consistent with Eysenck's conclusions. In his studies, melancholics produced an inhibitory response to all external stimuli, which holds true that melancholics shut out outside arousal, because they are deeply internally aroused. 14. Pavlov found that cholerics responded to stimuli with aggression and excitement whereas melancholics became depressed and unresponsive. 14. The high neuroticism which characterizes both melancholics and cholerics manifested itself differently in the two types because of the different levels of internal arousal they had. Emotion. Cannon-Bard theory. The Cannon-Bard theory is a theory of undifferentiated arousal, where the physical and emotional states occur at the same time in response to an event. This theory states that an emotionally provoking event results in both the physiological arousal and the emotion occurring concurrently. 16. For example, if a person's dear family member dies, a potential physiological response would be tears falling down the person's face and their throat feeling dry. They are sad. The Cannon-Bard theory states that the tears and the sadness both happen at the same time. The process goes: event, family member dies, right pointing arrow, physiological arousal, tears, and emotion, sadness simultaneously. 16. The fact that people can experience different emotions when they have the same pattern of physiological arousal is one argument in favor of the Cannon-Bard theory. For example, a person may have a heart racing and rapid breathing when they are angry or afraid. Even though not completely in accordance with the theory, it is taken as one piece of evidence in favor of the Cannon-Bard theory that physiological reactions sometimes happen more slowly than experiences of emotion. For example, if you are in the forest or woods, a sudden sound can create an immediate response of fear, while the physical symptoms of fear follow that feeling, and do not precede it. 17. James Lange theory. The James Lange theory describes how emotion is caused by the bodily changes which come from the perception of the emotionally arousing experience or environment. 18. This theory states that events cause the autonomic nervous system to induce physiological arousal, characterized by muscular tension, heart rate increases, perspiration, dryness of mouth, tears, etc. 19. According to James and Lange, the emotion comes as a result of the physiological arousal. 20. The bodily feeling is a reaction to the situation actually as the emotion. 18. For example, if someone just deeply insulted a person in their family, the person's fists might ball up and they might begin to perspire and become tense all around. The person feels that their fists are balled and that they are tense. The person then realizes that they are angry. The process here is: event, insult, to physiological arousal, balled fists, sweat, tension, to interpretation, I have balled fists, and tension, to emotion, anger, I am angry. 20. This type of theory emphasizes the physiological arousal is the key, in that the cognitive processes alone would not be sufficient evidence of an emotion. Schachter-Singer two-factor theory. The Schachter-Singer two-factor theory or the cognitive labeling theory takes into account both the physiological arousal and the cognitive processes that respond to an emotion-provoking situation. Schachter and Singer's theory states that an emotional state is the product of the physiological arousal and the cognition regarding the state of arousal. Thus, cognition determines how the physical response is labeled, for example, as anger, joy, or fear. 18. In this theory, emotion is seen as a product of the interaction between the state of arousal and how one's thought processes appraise the current situation. 21. The physiological arousal does not provide a label for the emotion, cognition does. For example, if a person is being pursued by a serial killer, the person will likely be sweating and their heart will be racing, which is their physiological state. The person's cognitive label will come from assessing their quickly beating heart and sweat as fear. Then they will feel the emotion of fear, but only after it has been established through cognition. The process is: the event, serial killer chasing the person, to physiological arousal, sweat, heart racing, to cognitive label, reasoning, this is fear, to emotion, fear. 20. Memory. Arousal is involved in the detection, retention, and retrieval of information in the memory process. Emotionally arousing information can lead to better memory encoding, therefore influencing better retention and retrieval of information. Arousal is related to selective attention during the encoding process by showing that people are more subject to encode arousing information than neutral information. 7. The selectivity of encoding arousing stimuli produces better long-term memory results than the encoding of neutral stimuli. 22. In other words, the retention and accumulation of information is strengthened when exposed to arousing events or information. Arousing information is also retrieved or remembered more vividly and accurately. 23. Although arousal improves memory under most circumstances, there are some considerations. Arousal at learning is associated more with long-term recall and retrieval of information than short-term recall of information. For example, one study found that people could remember arousing words better after 1 week of learning them than nearly 2 minutes after learning them. 24. Another study found that arousal affects the memory of people in different ways. Eysenck found an association between memory and the arousal of introverts versus extroverts. Higher levels of arousal increase the number of words retrieved by extroverts and decrease the number of words retrieved by introverts. 24. Preference. A person's level of arousal when introduced to stimuli can be indicative of their preferences. One study found that familiar stimuli are often preferred to unfamiliar stimuli. The findings suggested that the exposure to unfamiliar stimuli was correlated to avoidance behaviors. The unfamiliar stimuli may lead to increased arousal and increased avoidance behaviors. 25. On the contrary, increased arousal can increase approach behaviors as well. People are said to make decisions based on their emotional states. They choose specific options that lead to more favorable emotional states. 26. When a person is aroused, they may find a wider range of events appealing. 27. And view decisions as more salient, specifically influencing approach avoidance conflict. 26. The state of arousal might lead a person to view a decision more positively than they would have in a less aroused state. Memory. Arousal is involved in the detection, retention, and retrieval of information in the memory process. Emotionally arousing information can lead to better memory encoding, therefore influencing better retention and retrieval of information. Arousal is related to selective attention during the encoding process by showing that people are more subject to encode arousing information than neutral information. 7. The selectivity of encoding arousing stimuli produces better long-term memory results than the encoding of neutral stimuli. 22. In other words, the retention and accumulation of information is strengthened when exposed to arousing events or information. Arousing information is also retrieved or remembered more vividly and accurately. 23. Although arousal improves memory under most circumstances, there are some considerations. Arousal at learning is associated more with long-term recall and retrieval of information than short-term recall of information. For example, one study found that people could remember arousing words better after 1 week of learning them than nearly 2 minutes after learning them. 24. Another study found that arousal affects the memory of people in different ways. Eysenck found an association between memory and the arousal of introverts versus extroverts. Higher levels of arousal increase the number of words retrieved by extroverts and decrease the number of words retrieved by introverts. 24. Preference. A person's level of arousal when introduced to stimuli can be indicative of their preferences. One study found that familiar stimuli are often preferred to unfamiliar stimuli. The findings suggested that the exposure to unfamiliar stimuli was correlated to avoidance behaviors. The unfamiliar stimuli may lead to increased arousal and increased avoidance behaviors. 25. On the contrary, increased arousal can increase approach behaviors as well. People are said to make decisions based on their emotional states. They choose specific options that lead to more favorable emotional states. 26. When a person is aroused, they may find a wider range of events appealing. 27. And view decisions as more salient, specifically influencing approach avoidance conflict. 26. The state of arousal might lead a person to view a decision more positively than they would have in a less aroused state. The reversal theory accounts for the preference of either high or low arousal in different situations. Both forms of arousal can be pleasant or unpleasant, depending on a person's moods and goals at a specific time. 28. Wundt's and Berlin's hedonic curve differ from this theory. Both theorists explain a person's arousal potential in terms of their hedonic tone. These individual differences in arousal demonstrate Eysenck's theory that extroverts prefer increased stimulation and arousal, whereas introverts prefer lower stimulation and arousal. 29. Associated problems. Altered experiences of arousal are associated with both anxiety and depression. Depression can influence a person's level of arousal by interfering with the right hemisphere's functioning. Arousal in women has been shown to be slowed in the left visual field due to depression, indicating the influence of the right hemisphere. 30. Arousal and anxiety have a different relationship than arousal and depression. People with anxiety disorders tend to have abnormal and amplified perceptions of arousal. The distorted perceptions of arousal then create fear and distorted perceptions of the self. For example, a person may believe that he or she will get sick from being so nervous about taking an exam. The fear of the arousal of nervousness and how people will perceive this arousal will then contribute to levels of anxiety. 31. Abnormally increased behavioral arousal. This is caused by withdrawal from alcohol or barbiturates, acute encephalitis, head trauma resulting in coma, partial seizures and epilepsy, metabolic disorders of electrolyte imbalance, intracranial space-occupying lesions, Alzheimer's disease, rabies, hemispheric lesions and stroke and multiple sclerosis. 32. Anatomically this is a disorder of the limbic system, hypothalamus, temporal lobes, amygdala and frontal lobes. 32. It is not to be confused with mania. Effects of physiological arousal on cognition. The effects of physiological arousal on cognition cause individuals to be active, attentive, or excited. The term physiological refers to physiology and concerns the normal functioning of an organism. Physiological arousal refers to features of arousal reflected by physiological reactions, such as escalations in blood pressure and rate of respiration and lessened activity of the gastrointestinal system. These terms are what allow for the effects physiological arousal has on cognition itself. 33. Cognition is internal mental representations best characterized as thoughts and ideas resulting from and involved in multiple mental processes and operations including perception, reasoning, memory, intuition, judgment and decision-making. While cognition is not directly observable, it is still amenable to study using the scientific method. Cognition is also something that plays a fundamental role in determining behavior. Goes into explaining cognitive functions and how they are internal and inferred from behavior using measure-like accuracy and performing a task like recalling a list of words of the time taken to find some word on a page of text. The study of cognitive functions derived from the information processing approach 34, which argues that these functions involve operations occurring at various processing stages is typically based on a model of cognitive function of interest. Physiological comes from physiology, which is the study of the functioning of living organisms, animal or plant, and of the functioning of their constituent tissues or cells. This word was first used by the Greeks to describe a philosophical inquiry into the nature of things. The use of the term with specific reference to vital activities of healthy humans, which began in the 16th century, also applicable to many current aspects of physiology. Physiological response is to fight or flight. When the body is initially challenged by a stressor, it responds with physiological activation, also known as arousal, of a defense system to deal with the immediate stressor. If a stimulus is perceived as a threat, a more intense and prolonged discharge of the locus ceruleus, which is the major noradrenergic nucleus of the brain, giving rise to fibers innervating extensive areas throughout the neuroaxis. Also referred as the neuroaxis, is the axis in the central nervous system. Activates the sympathetic division of the autonomic nervous system. Thaysen Howland 1995, psychologistsworld.org, n.d. 35. The activation of the sympathetic nervous system leads to the release of non-epinephrine from nerve endings acting on the heart, blood vessels, respiratory centers, and other sites. The ensuing physiological changes constitute a major part of the acute stress response, which can often lead to as the fight or flight response. Anticipated behaviors are actions that are foreseen or predicted to happen in a specific situation due to different environmental factors. Furthermore, they are decided by one's past experiences and knowledge. Anticipated behaviors examples. Someone sitting in the same seat every day during class. Someone reaching their hand out towards you would indicate they are wanting to shake hands while driving a car. You would anticipate people braking, therefore you would brake as well when a loud unexpected noise is created. You are startled and flinch. When a person sneezes you say, "Bless you." A real-life example of cognition is used whenever decision-making is involved. For example, a real-life scenario of a cognitive decision would be when a traffic light is changing from green to yellow. One would either make a cognitive decision to run through the yellow light in hopes you could clear the intersection before the light turned red. However, one could make a different cognitive decision to stop when they see the yellow light to not run the light before it turned red. A real-life example of the effects of physiological arousal on cognition is when you're walking through the woods and you notice a rattlesnake in front of the walkway on the ground. You would feel alarmed and scared. Physiological arousal. Your past experience and knowledge of poisonous snakes and dangerous predators provides the cognition of the situation. Based on your analysis of your position, you label your arousal as fear. Fear is explained to be an emotion that one might expect with alarm. It is also known as something to be afraid of or the feelings of apprehensiveness. Fear works when one senses danger. The brain reacts instantly, sending signals that activate the nervous system. This causes physical responses, such as a faster heartbeat, rapid breathing, and an increase in blood pressure. Blood pumps to muscle groups to prepare the body for physical action like running or fighting. Skin sweats to keep the body cool. Some people might notice sensations in the stomach, head, chest, legs, or hands. These physical sensations of fear can be mild or strong. A study done by Joan Vickers and Mark Williams, 36, analyzed how a group of elite biathlon shooters handled an experimental task. The goal was to determine why there might be a failure to perform in high-pressure situations. Difficulties come about when trying to test performance pressure, physiological workload, anxiety, and visual attention in a controlled setting. Which is why they decided to test these elite biathlon shooters, due to the easy ability to stimulate the controlled experiment. In the low-pressure simulation, the subjects were only told that the purpose of the test was to simply provide feedback in the fixation on the target at different power output levels. In the high-pressure situation, the shooter were told that the national team coach was going to observe the shooters, and their shooting percentages would be used to make the national team selections. Both groups were told that prizes would be rewarded to the most accurate shooters. To test physiological arousal that was being used, Vickers and Williams measured each shooter's heart rate as well as the perceived exertion. Trying to determine if the failure to perform to whatever level of skill or ability the person has at the time, also known as choking, was indeed a factor in this test. Physiological arousal was measured and recorded through the athlete's heart rate and rate of perceived exertion. The findings showed that the biathletes develop the ability to decelerate their heart rate just before they shoot. Most only shoot when HR is 80% or lower. Whereas the test was designed for shots to be taken with a heart rate 100% or above. The expectations were for the low-pressure and high-pressure groups to be more prone to choking compared to those who were able to maintain their heart rates. The findings showed exactly what was expected. The only exception was that the pressure applied did not necessarily have much an effect. While it was clear that high-pressure stimulations did appear far more anxious than those of low-pressure stimulations. Problem solving is a cognitive process that someone uses to achieve a goal whenever a solution cannot be determined by others. For example, you are with your buddies on a trip and get a flat tire. Everyone looks around nervously because nobody knows how to change a flat. But then you remember that you took an automotive class in college where you learned to change flat tires. You change the tire and solve the issue with your cognitive problem solving. Cognitively, the utilization of logical analysis and problem solving has been associated with higher levels of life satisfaction, better health, and lower depression in caregivers. A realistic appraisal and acceptance of the difficult situation is healthy and allows the caregiver to live his or her own life while accommodating the needs of the recipient. Less effective cognitive coping styles include avoidant evasive, regressive, and an increased use of wishfulness and fantasizing by the caregiver, all of which have been related to higher levels of care burden. Haley et al. 1987, Quayhagen and Quayhagen, 1988. Cognitive appraisal is the stress perceived as imbalance between demands placed on the individual and the individual's resources to cope. Lazarus argued that the experience of stress differs significantly between individuals depending on how they interpret an event and the outcome of a specific sequence of thinking patterns called appraisals. It also refers to the personal interpretation of a situation that ultimately influences the extent to which a situation is perceived as stressful, process of assessing whether a situation or event threatens our well-being, whether there are sufficient personal resources available for coping with the demand of the situation, of whether our strategy for dealing with the situation is effective. The three parts that it can be divided into are primary appraisal, secondary appraisal, and reappraisal. Primary appraisal is an assessment of how significant an event is for a person, including whether it is a threat or opportunity, also including that no heightened physiological arousal occurs. It means no stressful either. Secondary appraisal considers one's ability to cope or take advantage of the situation. Cognitive appraisal is a personal interpretation of a situation and possible reactions to it. Their secondary appraisal determines what the person will do, and involves their perception of their options and resources. These appraisals can be accurate or inaccurate, and helping the person arrive at more apt appraisals is a goal of some modes of cognitive behavioral therapy. This is a psychosocial intervention that is the most widely used evidence-based practice for improving mental health guided by empirical research. Cognitive behavioral therapy focuses on the development of personal coping strategies that target solving current problems and changing unhelpful patterns in cognition, behaviors, and emotional regulation. Also known as regulation of emotion, is the ability to respond to the ongoing demands of experience with a range of emotions in a manner that is socially tolerable and sufficiently flexible to permit spontaneous reactions, as well as the ability to delay spontaneous reactions as needed. It can also be defined as extrinsic and intrinsic processes responsible for monitoring, evaluating, and modifying emotional reactions. Emotional self-regulation belongs to the broader set of emotion regulation processes, which includes the regulations of one's own feelings and the regulations of other people's feelings. Misattribution of arousal. In psychology, misattribution of arousal is the process whereby people make a mistake in assuming what is causing them to feel aroused. For example, when actually experiencing physiological responses related to fear, people mislabel those responses as romantic arousal. The reason physiological symptoms may be attributed to indirect stimuli is because many stimuli have similar physiological symptoms such as increased blood pressure or shortness of breath. One of the initial studies looking into this phenomenon, conducted by Schachter and Singer, 1962-37, was based on the idea that the experience of arousal could be ambiguous and therefore misattributed to an indirect stimulus. Operating under this assumption, the researchers developed the two-factor theory of emotion. Misattribution of arousal, which is an influence on emotion processing, can be found in multiple situations, such as romantic situations and physiological responses from exercise. An example of the possible effects of misattribution of arousal is perceiving a potential partner as more attractive because of a heightened state of physiological stress. A study done by White et al. 1981-38 investigated this phenomenon and found that those in an unrelated aroused state will rate an attractive confederate more highly than a rater without arousal. The researchers also found that aroused raters would dislike an unattractive confederate more than those without arousal. Forest fragmentation reduces food resources and habitat sources for animals, thus splitting these species apart. thus making these animals become much more susceptible to effects of predation and making them less likely to perform interbreeding, lowering genetic diversity. 67. Additionally, forest fragmentation affects the native plant species present within the area by dividing large populations into smaller ones. In turn, smaller populations are more inclined to be affected by genetic drift and population performance, as well as experience increases in inbreeding activities. 68. Moreover, fragmentation can affect the relationship present between animals and plants, such as the relationships regarding seed dispersal or pollinator-plant relationship. 68. 69. Implications. Forest fragmentation is one of the greatest threats to biodiversity in forests, especially in the tropics. 70. The problem of habitat destruction that caused the fragmentation in the first place is compounded by the inability of individual forest fragments to support viable populations, especially of large vertebrates. The local extinction of species that do not have at least one fragment capable of supporting a viable population. Edge effects that alter the conditions of the outer areas of the fragment, greatly reducing the amount of true forest interior habitat. 71. The effect of fragmentation on the flora and fauna of a forest patch depends on the size of the patch, and its degree of isolation. 72. Isolation depends on the distance to the nearest similar patch, and the contrast with the surrounding areas. For example, if a cleared area is reforested or allowed to regenerate, the increasing structural diversity of the vegetation will lessen the isolation of the forest fragments. However, when formerly forested lands are converted permanently to pastures, agricultural fields, or human-inhabited developed areas, the remaining forest fragments, and the biota within them, are often highly isolated. Forest patches that are smaller or more isolated will lose species faster than those that are larger or less isolated. A large number of small forest islands typically cannot support the same biodiversity that a single contiguous forest would hold, even if their combined area is much greater than a single forest. However, forest islands and rural landscapes greatly increase their biodiversity. 73. In the Malino forest of Chile, fragmentation appeared to not affect overall plant diversity much, and tree diversity is indeed higher in fragments than in large continuous forests. 74. 75. McGill University in Montreal, Quebec, Canada released a university-based newspaper statement stating that 70% of the world's remaining forest stands within 1 kilometer of a forest edge, putting biodiversity at an immense risk based on research conducted by international scientists. 76. Reduced fragment area, increased isolation, and increased edge initiate changes that percolate through all ecosystems. Habitat fragmentation is able to formulate persistent outcomes which can also become unexpected, such as an abundance of some species in the pattern that long temporal scales are required to discern many strong system responses. 7. Sustainable forest management. The presence of forest fragments influences the supply of various ecosystems in adjacent agricultural fields. Mitchell et al. 2014. Mitchell et al. 2014 researched on 6 varying ecosystem factors such as crop production, decomposition, pesticide regulation, carbon storage, soil fertility, and water quality regulation in soybean fields through separate distances by nearby forest fragments which all varied in isolation and size across an agricultural landscape in Quebec, Canada. Sustainable forest management can be achieved in several ways, including by managing forests for ecosystem services beyond simple provisioning, through government compensation schemes, and through effective regulation and legal frameworks. 77. The only realistic method of conserving forests is to apply and practice sustainable forest management to risk further loss. There is a high industrial demand for wood, pulp, paper, and other resources which the forest can provide with, thus businesses which will want more access to the cutting of forests to gain those resources. The Rainforest Alliance has efficiently been able to put into place an approach to sustainable forest management, and they established this in the late 1980s. Their conservation was deemed successful as it has saved over nearly 500 million acres of land around the world. 78. A few approaches and measures which can be taken in order to conserve forests are methods by which erosion can be minimized, waste is properly disposed, conserve native tree species to maintain genetic diversity, and setting aside forest land provides habitat for critical wildlife species. 78. Additionally, forest fires can also occur frequently, and measures can also be taken to further prevent forest fires from occurring. For example, in Guatemala's culturally and ecologically significant Petén region, researchers were able to find over a 20-year period, actively managed FSC-certified forests experienced substantially lower rates of deforestation than nearby protected areas, and forest fires only affected 0.1% of certified land area, compared to 10.4% of protected areas. 78. However, it must be duly noted that short-term decisions regarding forest sector employment and harvest practices can have long-term effects on biodiversity. 79. Planted forests become increasingly important as they supply approximately a quarter of global industrial roundwood production and are predicted to account for 50% of global output within 2 decades. Brown, 1998, Jaco Poiri, 1999. 80. Although there have been many difficulties, the implementation of forest certification has been quite prominent in being able to raise effective awareness and disseminating knowledge on a holistic concept, embracing economic environment portal, environmental and social issues, worldwide, while also providing a tool for a range of other applications in assessment of sustainability, such as e.g. verifying carbon sinks. 81. 2 approaches are typically used to understand habitat fragmentation and its ecological impacts. Species-oriented approach. The species-oriented approach focuses specifically on individual species and how they each respond to their environment and habitat changes within it. This approach can be limited because it does only focus on individual species and does not allow for a broad view of the impacts of habitat fragmentation across species. 82. Pattern-oriented approach. The pattern-oriented approach is based on land cover and its patterning in correlation with species occurrences. One model of study for landscape patterning is the patch matrix corridor model developed by Richard Foreman. The pattern-oriented approach focuses on land cover defined by human means and activities. This model has stemmed from island biogeography and tries to infer causal relationships between the defined landscapes and the occurrence of species or groups of species within them. The approach has limitations in its collective assumptions across species or landscapes which may not account for variations amongst them. 83. Variegation model. The other model is the variegation model. Variegated landscapes retain much of their natural vegetation but are intermixed with gradients of modified habitat. 84. This model of habitat fragmentation typically applies to landscapes that are modified by agriculture. In contrast to the fragmentation model that is denoted by isolated patches of habitat surrounded by unsuitable landscape environments, the variegation model applies to landscapes modified by agriculture where small patches of habitat remain near the remnant original habitat. In between these patches are a matrix of grassland that is often modified versions of the original habitat. These areas do not present as much a barrier to native species. 85. Empty forest. Approaches to understanding habitat fragmentation. Time scale. The geologic timescale or geological timescale (GTS) is a representation of time based on the rock record of Earth. It is a system of chronological dating that uses chronostratigraphy, the process of relating strata to time, and geochronology, a scientific branch of geology that aims to determine the age of rocks. It is used primarily by earth scientists, including geologists, paleontologists, geophysicists, geochemists, and paleoclimatologists to describe the timing and relationships of events in geologic history. The timescale has been developed through the study of rock layers and the observation of their relationships and identifying features such as lithologies, paleomagnetic properties, and fossils. The definition of standardized international units of geologic time is the responsibility of the International Commission on Stratigraphy (ICS), a constituent body of the International Union of Geological Sciences (IUGS), whose primary objective 1 is to precisely define global chronostratigraphic units of the International Chronostratigraphic Chart (ICC), 2 that are used to define divisions of geologic time. The chronostratigraphic divisions are in turn used to define geochronologic units. 2. The geologic time scale, proportionally represented as a log spiral with some major events in Earth's history. A megaannus Ma represents 1,106 years. Principles. The geologic timescale is a way of representing deep time based on events that have occurred throughout Earth's history, a time span of about 4.54 plus or minus 0.05 ga 4.54 billion years. 3. It chronologically organizes strata, and subsequently time, by observing fundamental changes in stratigraphy that correspond to major geological or paleontological events. For example, the Cretaceous-Paleogene extinction event marks the lower boundary of the Paleogene system period and thus the boundary between the Cretaceous and Paleogene systems periods. For divisions prior to the Cryogenian, arbitrary numeric boundary definitions, global standard stratigraphic ages, GSSAs, are used to divide geologic time. Proposals have been made to better reconcile these divisions with the rock record. 4. 5. Historically, regional geologic timescales were used 5 due to the litho and biostratigraphic differences around the world in time-equivalent rocks. The ICS has long worked to reconcile conflicting terminology by standardizing globally significant and identifiable stratigraphic horizons that can be used to define the lower boundaries of chronostratigraphic units. Defining chronostratigraphic units in such a manner allows for the use of global, standardized nomenclature. The International Chronostratigraphic Chart represents this ongoing effort. Several key principles are used to determine the relative relationships of rocks and thus their chronostratigraphic position. 6. 7. The law of superposition that states that in undeformed stratigraphic sequences the oldest strata will lie at the bottom of the sequence, while newer material stacks upon the surface. 8, 9, 10, 7. In practice, this means a younger rock will lie on top of an older rock unless there is evidence to suggest otherwise. The principle of original horizontality that states layers of sediments will originally be deposited horizontally under the action of gravity. 8, 10, 7. However, it is now known that not all sedimentary layers are deposited purely horizontally. 7, 11. But this principle is still a useful concept. The principle of lateral continuity that states layers of sediments extend laterally in all directions until either thinning out or being cut off by a different rock layer, i.e. they are laterally continuous. 8. Layers do not extend indefinitely. Their limits are controlled by the amount and type of sediment in a sedimentary basin, and the geometry of that basin. The principle of cross-cutting relationships that states a rock that cuts across another rock must be younger than the rock it cuts across. 8, 9, 10, 7. The law of included fragments that states small fragments of one type of rock that are embedded in a second type of rock must have formed first, and were included when the second rock was forming. 10, 7. The relationships of unconformities, which are geologic features representing a gap in the geologic record. Unconformities are formed during periods of erosion or non-deposition, indicating non-continuous sediment deposition. 7. Observing the type and relationships of unconformities in strata allows geologists to understand the relative time in the strata. The principle of faunal succession, where applicable, that states rock strata contain distinctive sets of fossils that succeed each other vertically in a specific and reliable order. 12. 7. This allows for a correlation of strata even when the horizon between them is not continuous. Divisions of geologic time. The geologic time scale is divided into chronostratigraphic units and their corresponding geochronologic units. An eon is the largest geochronologic time unit and is equivalent to a chronostratigraphic eon of them. 13. There are 4 formally defined eons: the Hadean, Archean, Proterozoic, and Phanerozoic. 2. An era is the second largest geochronologic time unit and is equivalent to a chronostratigraphic era of them. 14. 13. There are 10 defined eras: the Eoarchean, Paleoarchean, Mesoarchean, Neoarchean, Paleoproterozoic, Mesoproterozoic, Neoproterozoic, Paleozoic, Mesozoic, and Cenozoic, with none from the Hadean eon. 2. A period is equivalent to a chronostratigraphic system. 14. 13. There are 22 defined periods, with the current being the Quaternary period. 2. As an exception, 2 subperiods are used for the Carboniferous period. 14. An epoch is the second smallest geochronologic unit. It is equivalent to a chronostratigraphic series. 14. 13. There are 37 defined epochs and 1 informal one. The current epoch is the Holocene. There are also 11 subepochs which are all within the Neogene and Quaternary. 2. The use of subepochs as formal units in international chronostratigraphy was ratified in 2022. 1. 5. An age is the smallest hierarchical geochronologic unit. It is equivalent to a chronostratigraphic stage. 14. 13. There are 96 formal and 5 informal ages. 2. The current age is the Megalion. A chron is a non-hierarchical formal geochronology unit of unspecified rank and is equivalent to a chronostratigraphic chronozone. 14. These correlate with magnetostratigraphic, lithostratigraphic, or biostratigraphic units as they are based on previously defined stratigraphic units or geologic features. Formal, hierarchical units of the geologic time scale, largest to smallest height, chronostratigraphic unit, strata, geochronologic unit, time span, node 1. Eonathon eon several hundred million years to 2 billion years. Erathon era tens to hundreds of millions of years. System period millions of years to tens of millions of years. Series epoch hundreds of thousands of years to tens of millions of years. Subseries subepoch thousands of years to millions of years. Stage age thousands of years to millions of years. The subdivisions early and later used as the geochronologic equivalents of the chronostratigraphic lower and upper, e.g., early Triassic period geochronologic unit is used in place of lower Triassic system chronostratigraphic unit. Rocks representing a given chronostratigraphic unit are the chronostratigraphic unit, and the time they were laid down in is the geochronologic unit, e.g., the rocks that represent the Silurian system or the Silurian system and they were deposited during the Silurian period. This definition means the numeric age of a geochronologic unit can be changed and is more often subject to change when refined by geochronometry, while the equivalent chronostratigraphic unit, the revision of which is less frequent, remains unchanged. For example, in early 2022, the boundary between the Ediacaran and Cambrian periods geochronologic units was revised from 541 ma to 538.8 ma, but the rock definition of the boundary GSSP at the base of the Cambrian, and thus the boundary between the Ediacaran and Cambrian systems chronostratigraphic units has not been changed. Rather, the absolute age has merely been refined. Terminology. Chronostratigraphy is the element of stratigraphy that deals with the relation between rock bodies and the relative measurement of geological time. 14. It is the process where distinct strata between defined stratigraphic horizons are assigned to represent a relative interval of geologic time. A chronostratigraphic unit is a body of rock, layered or unlayered, that is defined between specified stratigraphic horizons which represent specified intervals of geologic time. They include all rocks representative of a specific interval of geologic time, and only this time span. Eonathon, erathon, system, series, subseries, stage, and substage are the hierarchical chronostratigraphic units. 14. A geochronologic unit is a subdivision of geologic time. It is a numeric representation of an intangible property of time. 16. These units are arranged in a hierarchy: eon, era, period, epoch, subepoch, age, and subage. 14. Geochronology is a scientific branch of geology that aims to determine the age of rocks, fossils, and sediments either through absolute, e.g., radiometric dating, or relative means, e.g., stratigraphic position, paleomagnetism, stable isotope ratios. Geochronometry is the field of geochronology that numerically quantifies geologic time. 16. A global boundary stratitype section and point GSSP is an internationally agreed upon reference point on a stratigraphic section that defines the lower boundaries of stages on the geologic time scale. 17. Recently this has been used to define the base of a system. 18. A global standard stratigraphic age GSSA 19 is a numeric-only, chronologic reference point used to define the base of geochronologic units prior to the cryogenian. These points are arbitrarily defined. 14. They are used where GSSPs have not yet been established. Research is ongoing to define GSSPs for the base of all units that are currently defined by GSSAs. The standard international units of the geologic timescale are published by the International Commission on Stratigraphy on the International Chronostratigraphic Chart. However, regional terms are still in use in some areas. The numeric values on the International Chronostratigraphic Chart are represented by the unit mega-annum per million years. For example, 201.4 plus or minus 0.2 Ma, the lower boundary of the Jurassic period, is defined as 201,400,000 years old with an uncertainty of 200,000 years. Other SI prefix units commonly used by geologists are Gott gigaannum, billion years, and Kok kiloannum, 1,000 years, with the latter often represented in calibrated units before present. Naming of geologic time. The names of geologic time units are defined for chronostratigraphic units with the corresponding geochronologic unit sharing the same name with a change to the suffix, e.g. Phanerozoic Eonathon becomes the Phanerozoic Eon. Names of erathons in the Phanerozoic were chosen to reflect major changes in the history of life on Earth: Paleozoic Old Life, Mesozoic Middle Life, and Cenozoic New Life. Names of systems are diverse in origin, with some indicating chronologic position, e.g., Paleogene, while others are named for lithology, e.g., Cretaceous, geography, e.g., Permian, or tribal, e.g., Ordovician, in origin. Most currently recognized series and subseries are named for their position within a system: series, early, middle, late. However, the International Commission on Stratigraphy advocates for all new series and subseries to be named for a geographic feature in the vicinity of its stratotype or type locality. The name of stages should also be derived from a geographic feature in the locality of its stratotype or type locality. 14. Informally, the time before the Cambrian is often referred to as the Precambrian or Precambrian Superan. 4. Note 2. Timespan and etymology of geologic Eonathon. Eon names hide. Name timespan. Duration, million years. Etymology of name. Phanerozoic 538.8 to 0, million years ago 538.8. From Greek phaneros. Phaneros. Visible, or abundant, and zoe, life. Proterozoic 2500 to 538.8, million years ago 1961.2. From Greek prateros, former, or earlier, and zoe, life. Archean 4031 to 2500, million years ago 1531. From Greek arche, beginning, origin. Hadine 4567.3 to 4031, million years ago 536.3. From Hades, ancient Greek, Hades. Romanized, Hades. The god of the underworld. The most modern geological timescale was not formulated until 1911, 36 by Arthur Holmes, 1890-1965, who drew inspiration from James Hutton, 1726-1797, a Scottish geologist who presented the idea of uniformitarianism, or the theory that changes to the Earth's crust resulted from continuous and uniform processes. 37. The broader concept of the relation between rocks and time can be traced back to, at least, the philosophers of ancient Greece from 1200 BC to 600 AD. Xenophanes of Colophon, circa 570 to 487 BCE, observed rock beds with fossils of seashells located above the sea level, viewed them as once living organisms. History of the geologic timescale. And used this to imply an unstable relationship in which the sea had at times transgressed over the land and at other times had regressed. 38. This view was shared by a few of Xenophanes' scholars and those that followed, including Aristotle 384 to 322 BC, who, with additional observations, reasoned that the positions of land and sea had changed over long periods of time. The concept of deep time was also recognized by Chinese naturalist Shen Kuo 39-1031-1095, and Islamic scientist philosophers, notably the Brothers of Purity, who wrote on the processes of stratification over the passage of time in their treatises. 38. Their work likely inspired that of the 11th century Persian polymath Avicenna Ibn Sina, 980-1037, who wrote in the Book of Healing, 1027, on the concept of stratification and superposition, predating Nicholas Steno by more than 6 centuries. 38. Avicenna also recognized fossils as petrifications of the bodies of plants and animals. 40. With the 13th century Dominican bishop Albertus Magnus circa 1200-1280, who drew from Aristotle's natural philosophy, extending this into a theory of a petrifying fluid. 41. These works appeared to have little influence on scholars in medieval Europe who looked to the Bible to explain the origins of fossils and sea level changes, often attributing these to the deluge, including Ristoro d'Arezzo in 1282. 38. It was not until the Italian Renaissance when Leonardo da Vinci 1452-1519 would reinvigorate the relationships between stratification, relative sea level change, and time, denouncing attribution of fossils to the deluge. 42-38. Of the stupidity and ignorance of those who imagined that these creatures were carried to such places distant from the sea by the deluge. Why do we find so many fragments and whole shells between the different layers of stone unless they had been upon the shore and had been covered over by earth newly thrown up by the sea which then became petrified? And if the above-mentioned deluge had carried them to these places from the sea, you would find the shells at the edge of one layer of rock only, not at the edge of many, where may be counted the winters of the years during which the sea multiplied the layers of sand and mud brought down by the neighboring rivers and spread them over its shores. And if you wish to say that there must have been many deluges in order to produce these layers and the shells among them, it would then become necessary for you to affirm that such a deluge took place every year. Sketch of the succession of strata and their relative altitudes, William Smith. These views of Da Vinci remained unpublished, and thus lacked influence at the time. However, questions of fossils and their significance were pursued and, while views against Genesis were not readily accepted and dissent from religious doctrine was in some places unwise, scholars such as Girolamo Fracastora shared Da Vinci's views, and found the attribution of fossils to the deluge absurd. 38. Although many theories surrounding philosophy and concepts of rocks were developed in earlier years, the first serious attempts to formulate a geological timescale that could be applied anywhere on Earth were made in the late 18th century. 41. Later, in the 19th century, academics further developed theories on stratification. William Smith, often referred to as the father of geology, 43, developed theories through observations rather than drawing from the scholars that came before him. Smith's work was primarily based on his detailed study of rock layers and fossils during his time, and he created the first map to depict so many rock formations over such a large area. 43. After studying rock layers and the fossils they contained, Smith concluded that each layer of rock contained distinct material that could be used to identify and correlate rock layers across different regions of the world. 44. Smith developed the concept of faunal succession, or the idea that fossils can serve as a marker for the age of the strata they are found in, and published his ideas in his 1816 book, Strata Identified by Organized Fossils. 44. Establishment of primary principles. Niels Stenson, more commonly known as Nicholas Steno, 1638-1686, is credited with establishing 4 of the guiding principles of stratigraphy. 45. In De Solido intra solidum naturaliter contendo dissertationis prodromus Steno states, 846. When any given stratum was being formed, all the matter resting on it was fluid, and, therefore, when the lowest stratum was being formed, none of the upper strata existed. Strata which are either perpendicular to the horizon or inclined to it were at one time parallel to the horizon. When any given stratum was being formed, it was either encompassed at its edges by another solid substance or it covered the whole globe of the earth. Hence, it follows that wherever bared edges of strata are seen, either a continuation of the same strata must be looked for or another solid substance must be found that kept the material of the strata from being dispersed. If a body or discontinuity cuts across a stratum, it must have formed after that stratum. Respectively, these are the principles of superposition, original horizontality, lateral continuity, and cross-cutting relationships. From this Steno reasoned that strata were laid down in succession and inferred relative time, in Steno's belief, time from creation. While Steno's principles were simple and attracted much attention, applying them proved challenging. 45. These basic principles, albeit with improved and more nuanced interpretations, still form the foundational principles of determining the correlation of strata relative to geologic time. Over the course of the 18th century, geologists realized that sequences of strata often become eroded, distorted, tilted, or even inverted after deposition. Strata laid down at the same time in different areas could have entirely different appearances. The strata of any given area represented only part of Earth's long history. Formulation of a modern geologic timescale. The apparent, earliest formal division of the geologic record with respect to time was introduced during the era of biblical models by Thomas Burnet, who applied a twofold terminology to mountains by identifying Montes Primari, for rock formed at the time of the deluge, and younger, Monticulos Secundarios, formed later from the debris of the Primari. 47-45. Anton Moro, 1687-1784, also used primary and secondary divisions for rock units, but his mechanism was volcanic. 48-45. In this early version of the Plutonism theory, the interior of Earth was seen as hot, and this drove the creation of primary igneous and metamorphic rocks, and secondary rocks formed contorted and fossiliferous sediments. These primary and secondary divisions were expanded on by Giovanni Tardoni Tazzati, 1712-1783, and Giovanni Arduino, 1713-1795, to include tertiary and quaternary divisions. 45. These divisions were used to describe both the time during which the rocks were laid down, and the collection of rocks themselves, i.e., it was correct to say tertiary rocks, and tertiary period. Only the quaternary division is retained in the modern geologic timescale, while the tertiary division was in use until the early 21st century. The Neptunism and Plutonism theories would compete into the early 19th century, with a key driver for resolution of this debate being the work of James Hutton, 1726-1797, in particular his theory of the Earth, first presented before the Royal Society of Edinburgh in 1785. 499-50. Hutton's theory would later become known as uniformitarianism, popularized by John Playfair, 51-1748-1819, and later Charles Lyell, 1797-1875, in his Principles of Geology. 1052-53. The theory strongly contested the 6,000-year age of the Earth as suggested determined by James Ussher via biblical chronology that was accepted at the time by Western religion. Instead, using geological evidence, they contested Earth to be much older, cementing the concept of deep time. During the early 19th century, William Smith, Georges Cuvier, Jean de Mallius de Halloy, and Alexander Brongniart pioneered the systematic division of rocks by stratigraphy and fossil assemblages. These geologists began to use the local names given to rock units in a wider sense, correlating strata across national and continental boundaries based on their similarity to each other. Many of the names below Eartham, era rank in use on the modern ICC GTS were determined during the early to mid-19th century. The advent of geochronometry. During the 19th century, the debate regarding Earth's age was renewed, with geologists estimating ages based on denudation rates and sedimentary thicknesses or ocean chemistry, and physicists determining ages for the cooling of the Earth or the Sun using basic thermodynamics or orbital physics. 3. These estimations vary from 15,000 million years to 0.075 million years depending on method and author, but the estimations of Lord Kelvin and Clarence King were held in high regard at the time due to their preeminence in physics and geology. All of these early geochronometric determinations would later prove to be incorrect. The discovery of radioactive decay by Henri Becquerel, Marie Curie, and Pierre Curie laid the groundwork for radiometric dating, but the knowledge and tools required for accurate determination of radiometric ages would not be in place until the mid-1950s. 3. Early attempts at determining ages of uranium minerals and rocks by Ernest Rutherford, Bertram Boltwood, Robert Strutt, and Arthur Holmes would culminate in what are considered the first international geological timescales by Holmes in 1911 and 1913. 5455-56. The discovery of isotopes in 1913-57 by Frederick Soddy, and the developments in mass spectrometry pioneered by Francis William Aston, Arthur Jeffrey Dempster, and Alfred O. Sr. during the early to mid-20th century would finally allow for the accurate determination of radiometric ages, with Holmes publishing several revisions to his geological timescale with his final version in 1960. 356-58-59. Modern International Geologic Timescale. The establishment of the IUGS in 1961-60 and acceptance of the Commission on Stratigraphy, applied in 1965-61 to become a member commission of IUGS, led to the founding of the ICS. One of the primary objectives of the ICS is the establishment, publication and revision of the ICS International Chronostratigraphic Chart, which is the standard, reference global geological timescale to include the ratified Commission decisions. 1. Following on from Holmes, several geological timescale books were published in 1982, 62 1989, 63 2004, 64 2008, 65 2012, 66 2016, 67 and 2020. 68. However, since 2013, the ICS has taken responsibility for producing and distributing the ICC, citing the commercial nature, independent creation, and lack of oversight by the ICS on the prior published GTS versions, GTS books prior to 2013, although these versions were published in close association with the ICS. 2. Subsequent geologic timescale books 2016, 67, and 2020, 68 are commercial publications with no oversight from the ICS, and do not entirely conform to the chart produced by the ICS. The ICS produced GTS charts are versioned year per month beginning at version 2013-01. At least one new version is published each year incorporating any changes ratified by the ICS since the prior version. The following 5 timelines show the geologic time scale to scale. The first shows the entire time from the formation of the Earth to the present, but this gives little space for the most recent eon. The second timeline shows an expanded view of the most recent eon. In a similar way, the most recent era is expanded in the third timeline, the most recent period is expanded in the fourth timeline, and the most recent epoch is expanded in the fifth timeline. Horizontal scale is millions of years above timelines, thousands of years below timeline. Major proposed revisions to the ICC. Proposed Anthropocene series epoch. First suggested in 2000, 69, the Anthropocene is a proposed epoch series for the most recent time in Earth's history. While still informal, it is a widely used term to denote the present geologic time interval, in which many conditions and processes on Earth are profoundly altered by human impact. 70. As of April 2022, the Anthropocene has not been ratified by the ICS. However, in May 2019, the Anthropocene Working Group voted in favor of submitting a formal proposal to the ICS for the establishment of the Anthropocene series epoch. 71. Nevertheless, the definition of the Anthropocene as a geologic time period rather than a geologic event remains controversial and difficult. 72, 73, 74, 75. Proposals for revisions to pre-cryogenian timeline. Shields et al., 2021. An international working group of the ICS on pre-cryogenian chronostratigraphic subdivision have outlined a template to improve the pre-cryogenian geologic timescale based on the rock record to bring it in line with the post-Tonian geologic timescale. 4. This work assesses the geologic history of the currently defined eons and eras of the Precambrian, Note 2, and the proposals in the Geological Timescale, Books 2004, 76, 2012, 5, and 2020. 77. The recommend revisions 4 of the pre-cryogenian geologic timescale where changes from the current scale B 2023-09 are italicized. 3 divisions of the Archean instead of 4 by dropping Neo-Archean, and revisions to their geochronometric definition, along with the repositioning of the Siderean into the latest Neo-Archean, and a potential Cretan division in the Neo-Archean. Archean 4024-50 ma. Paleo-Archean 4003-500 ma. Mesorchean 3500-300 ma. Neo-Archean 3024-50 ma. Cretan no fixed time given, prior to the Siderean, from Greek kratos, strength. Siderean 2450 ma, moved from Proterozoic to end of Archean, no start time given, base of Paleoproterozoic defines the end of the Siderean. The book, Geologic Timescale 2012, was the last commercial publication of an international chronostratigraphic chart that was closely associated with the ICS. 2. It included a proposal to substantially revise the pre-cryogenian timescale to reflect important events such as the formation of the solar system and the Great Oxidation Event, among others, while at the same time maintaining most of the previous chronostratigraphic nomenclature for the pertinent time span. 78. As of April 2022, these proposed changes have not been accepted by the ICS. The proposed changes from the current scale B 2023-09 are italicized. Hedenion 4567-403 ma. Chaucian era Eratham 4567-4404 ma, the name alluding both to the mythological chaos and the chaotic phase of planet formation. 66, 79, 80. This table is arranged with the most recent geologic periods at the top, and the oldest at the bottom. The height of each table entry does not correspond to the duration of each subdivision of time. As such, this table is not to scale and does not accurately represent the relative time spans of each geochronologic unit. While the Phanerozoic eon looks longer than the rest, it merely spans approximately 539 million years, approximately 12% of Earth's history, whilst the previous 3 eons, Note 2, collectively span approximately 3,461 million years, approximately 76% of Earth's history. This bias toward the most recent eon is in part due to the relative lack of information about events that occurred during the first 3 eons compared to the current eon, the Phanerozoic. 483. The use of subseries Subabox has been ratified by the ICS. 15. While some regional terms are still in use, 5. The table of geologic time conforms to the nomenclature, ages, and color codes set forth by the International Commission on Stratigraphy and the official International Chronostratigraphic Chart. 184. The International Commission on Stratigraphy also provide an online interactive version of this chart. The interactive version is based on a service delivering a machine-readable resource description framework, web ontology language representation of the time scale, which is available through the Commission for the Management and Application of Geoscience Information GOCML project as a service 85 and ISPARQL endpoint. 86, 87. Non-Earth-based geologic timescales. Some other planets and satellites in the solar system have sufficiently rigid structures to have preserved records of their own histories. For example, Venus, Mars, and the Earth's moon. Dominantly fluid planets, such as the giant planets, do not comparably preserve their history. Apart from the late heavy bombardment, events on other planets probably have little direct influence on the Earth, and events on Earth had correspondingly little effect on those planets. Construction of a timescale that links the planets is, therefore, of only limited relevance to the Earth's timescale, except in a solar system context. The existence, timing, and terrestrial effects of the late heavy bombardment are still a matter of debate. Note 12. Lunar Selenological Timescale. The geologic history of Earth's moon has been divided into a timescale based on geomorphological markers, namely impact cratering, volcanism, and erosion. This process of dividing the moon's history in this manner means that the timescale boundaries do not imply fundamental changes in geological processes, unlike Earth's geologic timescale. 5 geologic systems periods pre-Nectarian, Nectarian, Imbrian, Eratosthenian, Copernican, with the Imbrian divided into 2 series epochs early and late, were defined in the latest lunar geologic timescale. 105 The moon is unique in the solar system in that it is the only other body from which humans have rock samples with a known geological context. Millions of years before present. Martian geologic timescale. The geological history of Mars has been divided into 2 alternate timescales. The first timescale for Mars was developed by studying the impact crater densities on the Martian surface. Through this method 4 periods have been defined: the pre-Noachian approximately 4,500-4,100 Ma, Noachian approximately 4,100-3,700 Ma, Hesperian approximately 3,700-3,000 Ma, and Amazonian approximately 3,000 Ma to present. 106-107. Martian time periods millions of years ago. Epochs. Geology portal. A second time scale based on mineral alteration observed by the Omega spectrometer on board the Mars Express. Reproductive isolation. The mechanisms of reproductive isolation are a collection of evolutionary mechanisms, behaviors and physiological processes critical for speciation. They prevent members of different species from producing offspring, or ensure that any offspring are sterile. These barriers maintain the integrity of a species by reducing gene flow between related species. 1, 2, 3, 4. The mechanisms of reproductive isolation have been classified in a number of ways. Zoologist Ernst Mayr classified the mechanisms of reproductive isolation in two broad categories: prezygotic for those that act before fertilization or before mating in the case of animals, and postzygotic for those that act after it. 5. The mechanisms are genetically controlled and can appear in species whose geographic distributions overlap, sympatric speciation, or as separate allopatric speciation. Prezygotic isolation. Prezygotic isolation mechanisms are the most economic in terms of the natural selection of a population, as resources are not wasted on the production of a descendant that is weak, non-viable or sterile. These mechanisms include physiological or systemic barriers to fertilization. Temporal or habitat isolation. The Central Valley in California prevents the two salamander populations from interacting with each other, which is an example of habitat isolation. After many generations, the two salamander gene pools will become mutated caused by natural selection. The mutation will change the DNA sequence of the two populations enough that the salamander populations can no longer successfully breed between each other, making the populations of salamander become classified as different species. Any of the factors that prevent potentially fertile individuals from meeting will reproductively isolate the members of distinct species. The types of barriers that can cause this isolation include different habitats, physical barriers, and a difference in the time of sexual maturity or flowering. 6, 7. An example of the ecological or habitat differences that impede the meeting of potential pairs occurs in two fish species of the family Gastroseidae, sticklebacks. One species lives all year round in fresh water, mainly in small streams. The other species lives in the sea during winter, but in spring and summer individuals migrate to river estuaries to reproduce. The members of the two populations are reproductively isolated due to their adaptations to distinct salt concentrations. 6. An example of reproductive isolation due to differences in the mating season are found in the toad species Bufo americanus and Bufo fowleri. The members of these species can be successfully crossed in the laboratory, producing healthy, fertile hybrids. However, mating does not occur in the wild even though the geographical distribution of the two species overlaps. The reason for the absence of interspecies mating is that B. americanus mates in early summer and B. fowleri in late summer. 6. Certain plant species, such as Stratoscantia canaliculata and T. subispera, are sympatric throughout their geographic distribution, yet they are reproductively isolated as they flower at different times of the year. In addition, one species grows in sunny areas and the other in deeply shaded areas. 3, 7. Behavioral isolation. The different mating rituals of animal species creates extremely powerful reproductive barriers, termed sexual or behavior isolation, that isolate apparently similar species in the majority of the groups of the animal kingdom. In dioecious species, males and females have to search for a partner, be in proximity to each other, carry out the complex mating rituals and finally copulate or release their gametes into the environment in order to breed. 8, 9, 10. 0, 26. The songs of birds, insects and many other animals are part of a ritual to attract potential partners of their own species. The song presents specific patterns recognizable only by members of the same species, and therefore represents a mechanism of reproductive isolation. This recording is the song of a species of cicada, recorded in New Zealand. Mating dances, the songs of males to attract females or the mutual grooming of pairs, are all examples of typical courtship behavior that allows both recognition and reproductive isolation. This is because each of the stages of courtship depend on the behavior of the partner. The male will only move on to the second stage of the exhibition if the female shows certain responses in her behavior. He will only pass on to the third stage when she displays the second key behavior. The behaviors of both interlink, are synchronized in time and led finally to copulation or the liberation of gametes into the environment. No animal that is not physiologically suitable for fertilization can complete this demanding chain of behavior. In fact, the smallest difference in the courting patterns of two species is enough to prevent mating. For example, a specific song pattern acts as an isolation mechanism in distinct species of grasshopper of the genus Cherthipus 11. Even where there are minimal morphological differences between species, differences in behavior can be enough to prevent mating. For example, Drosophila melanogaster and D. simulans, which are considered twin species due to their morphological similarity, do not mate even if they are kept together in a laboratory. 312 Drosophila ananaceae and D. pallidos are twin species from Melanesia. In the wild they rarely produce hybrids, although in the laboratory it is possible to produce fertile offspring. Studies of their sexual behavior show that the males court the females of both species, but the females show a marked preference for mating with males of their own species. A different regulator region has been found on chromosome 2 of both species that affects the selection behavior of the females. 12. Pheromones play an important role in the sexual isolation of insect species. 13. These compounds serve to identify individuals of the same species and of the same or different sex. Evaporated molecules of volatile pheromones can serve as a wide-reaching chemical signal. In other cases, pheromones may be detected only at a short distance or by contact. In species of the melanogaster group of Drosophila, the pheromones of the females are mixtures of different compounds. There is a clear dimorphism in the type and/or quantity of compounds present for each sex. In addition, there are differences in the quantity and quality of constituent compounds between related species. It is assumed that the pheromones serve to distinguish between individuals of each species. An example of the role of pheromones in sexual isolation is found in corn borers in the genus Ostrenia. There are two twin species in Europe that occasionally cross. The females of both species produce pheromones that contain a volatile compound which has two isomers, E and Z. 99% of the compound produced by the females of one species is in the isomer form, while the females of the other produce 99% isomers E. The production of the compound is controlled by just one locus, and the interspecific hybrid produces an equal mix of the two isomers. The males, for their part, almost exclusively detect the isomer emitted by the females of their species, such that the hybridization, although possible, is scarce. The perception of the males is controlled by one gene, distinct from the one for the production of isomers. The heterozygous males show a moderate response to the odor of either type. In this case, just two loci produce the effect of ethological isolation between species that are genetically very similar. 12. Sexual isolation between two species can be asymmetrical. This can happen when the mating that produces descendants only allows one of the two species to function as the female progenitor and the other as the male, while the reciprocal cross does not occur. For instance, half of the wolves tested in the Great Lakes area of America show mitochondrial DNA sequences of coyotes, while mitochondrial DNA from wolves is never found in coyote populations. This probably reflects an asymmetry in interspecies mating due to the difference in size of the two species, as male wolves take advantage of their greater size in order to mate with female coyotes, while female wolves and male coyotes do not mate. 14. Mechanical isolation. The flowers of many species of angiosperm have evolved to attract and reward a single or a few pollinator species, insects, birds, mammals. Their wide diversity of form, color, fragrance and presence of nectar is, in many cases, the result of coevolution with the pollinator species. This dependency on its pollinator species also acts as a reproductive isolation barrier. Mating pairs may not be able to couple successfully if their genitals are not compatible. The relationship between the reproductive isolation of species in the form of their genital organs was signaled for the first time in 1844 by the French entomologist Léon Dufour. 15. Insects' rigid carapaces act in a manner analogous to a lock and key, as they will only allow mating between individuals with complementary structures, that is, males and females of the same species, termed co-specifics. Evolution has led to the development of genital organs with increasingly complex and divergent characteristics, which will cause mechanical isolation between species. Certain characteristics of the genital organs will often have converted them into mechanisms of isolation. However, numerous studies show that organs that are anatomically very different can be functionally compatible, indicating that other factors also determine the form of these complicated structures. 16. Mechanical isolation also occurs in plants, and this is related to the adaptation and coevolution of each species in the attraction of a certain type of pollinator, where pollination is zoophilic through a collection of morphophysiological characteristics of the flowers called pollination syndrome, in such a way that the transport of pollen to other species does not occur. 17. Gametic isolation. The synchronous spawning of many species of coral in marine reefs means that interspecies hybridization can take place as the gametes of hundreds of individuals of tens of species are liberated into the same water at the same time. Approximately a third of all the possible crosses between species are compatible, in the sense that the gametes will fuse and lead to individual hybrids. This hybridization apparently plays a fundamental role in the evolution of coral species. 18. However, the other two-thirds of possible crosses are incompatible. It has been observed that in sea urchins of the genus Strongylocentrotus the concentration of spermatocytes that allow 100% fertilization of the ovules of the same species is only able to fertilize 1.5% of the ovules of other species. This inability to produce hybrid offspring, despite the fact that the gametes are found at the same time and in the same place, is due to a phenomenon known as gamete incompatibility, which is often found between marine invertebrates, and whose physiological causes are not fully understood. 19. 20. In some Drosophila crosses, the swelling of the female's vagina has been noted following insemination. This has the effect of consequently preventing the fertilization of the ovule by sperm of a different species. 21. In plants, the pollen grains of a species can germinate in the stigma and grow in the style of other species. However, the growth of the pollen tubes may be detained at some point between the stigma and the ovules, in such a way that fertilization does not take place. This mechanism of reproductive isolation is common in the angiosperms and is called cross-incompatibility or incongruence. 22. 23. A relationship exists between self-incompatibility and the phenomenon of mating dances. The songs of males to attract females or the mutual grooming of pairs, are all examples of typical courtship behavior that allows both recognition and reproductive isolation. This is because each of the stages of courtship depend on the behavior of the partner. The male will only move on to the second stage of the exhibition if the female shows certain responses in her behavior. He will only pass on to the third stage when she displays the second key behavior. The behaviors of both interlink, are synchronized in time and led finally to copulation or the liberation of gametes into the environment. No animal that is not physiologically suitable for fertilization can complete this demanding chain of behavior. In fact, the smallest difference in the courting patterns of two species is enough to prevent mating. For example, a specific song pattern acts as an isolation mechanism in distinct species of grasshopper of the genus Strythipus 11. Even where there are minimal morphological differences between species, differences in behavior can be enough to prevent mating. For example, Drosophila melanogaster and D. simulans, which are considered twin species due to their morphological similarity, do not mate even if they are kept together in a laboratory. 312 Drosophila ananaceae and D. pallidos are twin species from Melanesia. In the wild they rarely produce hybrids, although in the laboratory it is possible to produce fertile offspring. Studies of their sexual behavior show that the males court the females of both species, but the females show a marked preference for mating with males of their own species. A different regulator region has been found on chromosome 2 of both species that affects the selection behavior of the females. 12. Pheromones play an important role in the sexual isolation of insect species. 13. These compounds serve to identify individuals of the same species and of the same or different sex. Evaporated molecules of volatile pheromones can serve as a wide-reaching chemical signal. In other cases, pheromones may be detected only at a short distance or by contact. In species of the melanogaster group of Drosophila, the pheromones of the females are mixtures of different compounds. There is a clear dimorphism in the type and or quantity of compounds present for each sex. In addition, there are differences in the quantity and quality of constituent compounds between related species. It is assumed that the pheromones serve to distinguish between individuals of each species. An example of the role of pheromones in sexual isolation is found in corn borers in the genus Ostrinia. There are two twin species in Europe that occasionally cross. The females of both species produce pheromones that contain a volatile compound which has two isomers, E and Z. 99% of the compound produced by the females of one species is in the isomer form, while the females of the other produce 99% isomers E. The production of the compound is controlled by just one locus, and the interspecific hybrid produces an equal mix of the two isomers. The males, for their part, almost exclusively detect the isomer emitted by the females of their species, such that the hybridization, although possible, is scarce. The perception of the males is controlled by one gene, distinct from the one for the production of isomers. The heterozygous males show a moderate response to the odor of either type. In this case, just two loci produce the effect of ethological isolation between species that are genetically very similar. 12. Sexual isolation between two species can be asymmetrical. This can happen when the mating that produces descendants only allows one of the two species to function as the female progenitor and the other as the male, while the reciprocal cross does not occur. For instance, half of the wolves tested in the Great Lakes area of America show mitochondrial DNA sequences of coyotes, while mitochondrial DNA from wolves is never found in coyote populations. This probably reflects an asymmetry in interspecies mating due to the difference in size of the two species, as male wolves take advantage of their greater size in order to mate with female coyotes, while female wolves and male coyotes do not mate. 14. Mechanical isolation. The flowers of many species of angiosperm have evolved to attract and reward a single or a few pollinator species, insects, birds, mammals. Their wide diversity of form, color, fragrance and presence of nectar is, in many cases, the result of coevolution with the pollinator species. This dependency on its pollinator species also acts as a reproductive isolation barrier. Mating pairs may not be able to couple successfully if their genitals are not compatible. The relationship between the reproductive isolation of species in the form of their genital organs was signaled for the first time in 1844 by the French entomologist Léon Dufour. 15. Insects' rigid carapaces act in a manner analogous to a lock and key, as they will only allow mating between individuals with complementary structures, that is, males and females of the same species termed co-specifics. Evolution has led to the development of genital organs with increasingly complex and divergent characteristics, which will cause mechanical isolation between species. Certain characteristics of the genital organs will often have converted them into mechanisms of isolation. However, numerous studies show that organs that are anatomically very different can be functionally compatible, indicating that other factors also determine the form of these complicated structures. 16. Mechanical isolation also occurs in plants, and this is related to the adaptation and coevolution of each species in the attraction of a certain type of pollinator, where pollination is zoophilic through a collection of morphophysiological characteristics of the flowers called pollination syndrome, in such a way that the transport of pollen to other species does not occur. 17. Gametic isolation. The synchronous spawning of many species of coral in marine reefs means that interspecies hybridization can take place as the gametes of hundreds of individuals of tens of species are liberated into the same water at the same time. Approximately a third of all the possible crosses between species are compatible, in the sense that the gametes will fuse and lead to individual hybrids. This hybridization apparently plays a fundamental role in the evolution of coral species. 18. However, the other two-thirds of possible crosses are incompatible. It has been observed that in sea urchins of the genus Strongylocentrotus the concentration of spermatocytes that allow 100% fertilization of the ovules of the same species is only able to fertilize 1.5% of the ovules of other species. This inability to produce hybrid offspring, despite the fact that the gametes are found at the same time and in the same place, is due to a phenomenon known as gamete incompatibility, which is often found between marine invertebrates, and whose physiological causes are not fully understood. 19. 20. In some Drosophila crosses, the swelling of the female's vagina has been noted following insemination. This has the effect of consequently preventing the fertilization of the ovule by sperm of a different species. 21. In plants, the pollen grains of a species can germinate in the stigma and grow in the style of other species. However, the growth of the pollen tubes may be detained at some point between the stigma and the ovules, in such a way that fertilization does not take place. This mechanism of reproductive isolation is common in the angiosperms and is called cross-incompatibility or incongruence. 22. 23. A relationship exists between self-incompatibility and the phenomenon of cross-incompatibility. In general, crosses between individuals of a self-compatible species SC with individuals of a self-incompatible SI species give hybrid offspring. On the other hand, a reciprocal cross SI-XSC will not produce offspring, because the pollen tubes will not reach the ovules. This is known as unilateral incompatibility, which also occurs when two SC or two SI species are crossed. 24. In coral reefs, gamete incompatibility prevents the formation of numerous interspecies hybrids. Postzygotic isolation. A number of mechanisms which act after fertilization preventing successful interpopulation crossing are discussed below. Zygote mortality and non-viability of hybrids. A type of incompatibility that is found as often in plants as in animals occurs when the egg or ovule is fertilized but the zygote does not develop, or it develops and the resulting individual has a reduced viability. 3. This is the case for crosses between species of the frog order, where widely differing results are observed depending upon the species involved. In some crosses there is no segmentation of the zygote, or it may be that the hybrid is extremely non-viable and changes occur from the first mitosis. In others, normal segmentation occurs in the blastula but gastrulation fails. Finally, in other crosses, the initial stages are normal but errors occur in the final phases of embryo development. This indicates differentiation of the embryo development genes, or gene complexes, in these species, and these differences determine the non-viability of the hybrids. 25. Similar results are observed in mosquitoes of the genus Culex, but the differences are seen between reciprocal crosses, from which it is concluded that the same effect occurs in the interaction between the genes of the cell nucleus inherited from both parents, as occurs in the genes of the cytoplasmic organelles which are inherited solely from the female progenitor through the cytoplasm of the ovule. 3. In angiosperms, the successful development of the embryo depends on the normal functioning of its endosperm. 26. The failure of endosperm development and its subsequent abortion has been observed in many interploidal crosses, that is, those between populations with a particular degree of inter- or interspecific ploidy, 26, 27, 28, 29, 30, and in certain crosses in species with the same level of ploidy. 30, 31, 32, the collapse of the endosperm, and the subsequent abortion of the hybrid embryo is one of the most common post-fertilization reproductive isolation mechanism found in angiosperms. Hybrid sterility. Mules are hybrids with interspecific sterility. A hybrid may have normal viability but is typically deficient in terms of reproduction or is sterile. This is demonstrated by the mulin and many other well-known hybrids. In all of these cases, sterility is due to the interaction between the genes of the two species involved, to chromosomal imbalances due to the different number of chromosomes in the parent species, or to nucleus cytoplasmic interactions such as in the case of Culex described above. 3. Kidneys and mules are hybrids resulting from a cross between a horse and a donkey or between a mare and a donkey, respectively. These animals are nearly always sterile due to the difference in the number of chromosomes between the two parent species. Both horses and donkeys belong to the genus Equus, but Equus cavalus has 64 chromosomes, while Equus asinus only has 62. A cross will produce offspring, mule or hinny, with 63 chromosomes, that will not form pairs, which means that they do not divide in a balanced manner during meiosis. In the wild, the horses and donkeys ignore each other and do not cross. In order to obtain mules or hinnies, it is necessary to train the progenitors to accept copulation between the species or create them through artificial insemination. The sterility of many interspecific hybrids in angiosperms has been widely recognized and studied. 33. Interspecific sterility of hybrids in plants has multiple possible causes. These may be genetic, related to the genomes, or the interaction between nuclear and cytoplasmic factors, as will be discussed in the corresponding section. Nevertheless, in plants, hybridization is a stimulus for the creation of new species, the contrary to the situation in animals. 34. Although the hybrid may be sterile, it can continue to multiply in the wild by asexual reproduction, whether vegetative propagation or apomixis or the production of seeds. 35. 36. Indeed, interspecific hybridization can be associated with polyploidy and, in this way, the origin of new species that are called allopolyploids. Rosa canina, for example, is the result of multiple hybridizations. 37. The common wheat, Triticum estivum, is an allohexaploid allopolyploid with 6 chromosome sets that contains the genomes of 3 different species. 38. 39. Multiple mechanisms. In general, the barriers that separate species do not consist of just one mechanism. The twin species of Drosophila, D. pseudoobscura and D. persimilis, are isolated from each other by habitat. Persimilis generally lives in colder regions at higher altitudes. By the timing of the mating season, Persimilis is generally more active in the morning and pseudoobscura at night, and by behavior during mating, the females of both species prefer the males of their respective species. In this way, although the distribution of these species overlaps in wide areas of the west of the United States of America, these isolation mechanisms are sufficient to keep the species separated. such that only a few fertile females have been found amongst the other species among the thousands that have been analyzed. However, when hybrids are produced between both species, the gene flow between the two will continue to be impeded as the hybrid males are sterile. Also, and in contrast with the great vigor shown by the sterile males, the descendants of the back crosses of the hybrid females with the parent species are weak and notoriously non-viable. This last mechanism restricts even more the genetic interchange between the two species of fly in the wild, such that only a few fertile females have been found amongst the other species among the thousands that have been analyzed. However, when hybrids are produced